Hello everyone. In this video, we are going to see the types of bolted joints and what are the different failures which occur in the case of bolted connections. So let's start. Now these bolted joints can be classified into a number of categories depending upon the different patterns. So the first method of classification is based upon the depending upon the pattern of the bolts. So if the bolts are provided in a single line, that means one after the other, then that type of connection is known as the single line connection. Now if the number of bolts are provided in a single line and another line is provided below that and the arrangement is made in such a way that the lines are coinciding, then that type of connection is known as the chain line connection, or that is known as the chaining pattern. Third type of pattern can be the one in which these connections, in which these bolts are staggered to each other, and that's why the name comes as the staggered connection, or it is also known as the zigzag pattern of the arrangement of the bolts. It is done so as to reduce the bolt hole area from the plate. As you can see from the first diagram and the second diagram, that in the first diagram the total number of bolts that were provided, that is 1, 2 and 3, and in 5 columns, that means the total number of bolts were provided were the 15. That means 15 bolt holes were to be made. Now in the second case, the total number of bolt holes are 1, 2, 3, 4, 5, 6 and 7, 8, 9, and 4 of them, that is 13. That means we have reduced the bolt hole area by 2 numbers. Therefore, it is advantageous when we need to strengthen the plate. That means we are reducing the bolt hole area so as to strengthen the plate. And third type of pattern of the bolt can be made in such a way that the number of bolts keeps on increasing as we move towards the center of the plate. So this type of pattern of the arrangement of the bolt, that is known as the diamond pattern, and which is the best method for providing the bolts. So these are the 4 types of bolting connection which can be provided based upon the different patterns. Now the second classification can be based upon the arrangement of the bolts and the plates. Primarily it is depending upon the arrangement of the plates. So it is classified into 2 categories, that is a lap joint and the second one is known as the butt joint. It is the major classification in the case of the bolted joints. So the lap joint means the two of the plates which are to be connected, they are to be overlap each other. They are to overlap each other. Now that means when we are providing the connection between the two plates or the two elements, they are to be overlapping each other. So this is the overlapping distance. Now in this overlapping distance, we provide the bolt hole, and in that we derive the bolt of suitable diameter. And that's how we provide the connection. Now, depending upon the number of bolts that are provided here, it can be further classified into different categories that we will see in the upcoming slide. Now, this butt joint is when we provide the connection between the two plates when they are placed edge to each other. When they are placed edge to each other, in this case, as you can see, we cannot provide the connection directly between the two members. So for this, we take the help of the additional plates, and that plate is provided either above the two plates or below the two plates. And this additional plate is known as the cover plate. And now the bolts are provided through them. That means one bolt for the each plate. Now depending upon the number of cover plates, the cover plate can be provided either on the top or on the below of the two members or on both the sides, and the number of bolts can be increased. And depending upon these arrangements, we can further classify these butt joints into different categories. So these lap joints are classified into 2 categories, that is a single bolted lap joint and the double bolted lap joint. That means if we are providing a single chain of the bolts, then that type of lap joint is known as the single bolted lap joint. And if we are providing the two rows of the bolts, then that type of lap joint is known as the double bolted lap joint. And if we are providing multiple rows of the bolts, then that type of lap joint is known as the multiple bolted lap joint. Now this butt joint can be classified into three categories. The first one is that when we are providing two plates, that is, this is one plate which is pulled apart, and this is the another plate which is in the other direction. At the edge part of these two plates, we are providing a cover plate, and with the help of the cover plate, we are providing the bolt connection. These are the two bolts which are having the connection between them with the help of the cover plate. So since we are providing single cover plate, that is known as a single cover, and for each plate that is to be connected, we have provided a single row of the bolt. So that is known as a single cover, single bolted butt joint. Now if we provide the cover plate on both the sides of the members which are to be connected, then that will be known as the double cover, since we have provided the cover plate on both the sides, and still we are providing only one bolt for each plate. That's why it will be known as double cover, single bolted butt joint. In the next classification, we can have the two cover plates, that is on both the sides of the elements to be connected, and we are providing two chains of the bolts for each plate. So that means it will be double cover, since two cover plates are provided, and it will be double cover, double bolted, because for each plate we are providing two rows of the bolts. So it is double cover, double bolted butt joints. Similarly, depending upon the number of cover plates, which can be increased up to 2, and depending upon the number of rows of the bolts which are provided, which can be up to n value, it can be classified upon that category. So it will be double cover, n bolted butt joints, depending upon the value of the n. Now the another classification is made depending upon the mode of the load transmission. Now depending upon the mode of the load transmission, it is classified into single shear, that means bolt is subjected to single shear, or it may be double shear, or it may be multiple shear. And what is the meaning of this, the single shear, double shear, and the multiple shear, that we will see in a while. So let's say this is the first type of connection which is provided, and you can see from the diagram that it is a lap joint. So therefore these type of shear failure or the shear mode of load transmission is evident in the case of the lap joint primarily, although it is possible in the case of the butt joint also, but it is primarily evident in the case of lap joint. So in this we can see that these two plates are overlapping each other, and through the plates we have provided one bolt to connect them together. Now when the tensile force is acting on both the plates, they will be pulled apart, and because of that the interface between them, that will be experiencing a force, and a force which is parallel to the plane on which it is acting, then that type of force is known as the shear force. So on the interface it will be experiencing the shear force because of the tensile force or the compressive force, whichever is there. Now depending upon the number of interfaces present between the different plates, we have classified them into single shear, double shear, and the multiple shear. If the plates are having only one interface, that means only along the one face the shear force will be acting, and that is known as the single shear. If we have provided multiple plates and between them we are having two interfaces, that means the shear force will be acting along the two of the interfaces, that is known as the double shear. And if we have provided multiple number of plates and between them we are having multiple interfaces, that means there will be a case of multiple shear. Now if a P force is acting in the case of single shear, then on both the sides it will be P force. Now in the case of the double shear, if along the one direction this is P force, and this will be, let's say this is PD and PD, that is the double shear force. So from the force equilibrium, we can see that this twice of the PD value, because it is in this direction. So twice of this PD value, that will be equal to this P value. So from here we get this PD value as P by 2. And you can see from this diagram that depending upon the force equilibrium, we have classified them into the double shear. So for double shear, the plate which is sandwiched between the two different plates, if it is experiencing F force, then the plates which are sandwiching them, then they will be experiencing F by 2 force. The next mode of classification can be based upon the nature and the location of the load. So in this, the first category is the direct shear connection. That means if we are having a connection in such a way that the two plates are connected and they are pulled apart, that means the bolts which are provided here, they will be experiencing a tensile force only, and because of that the connection will be experiencing a shear force only. So that type of connection is known as the direct shear connection. Second type of connection is known as the eccentric connection. Now in the eccentric connection, what we are doing, if let's say this is one column, and if it is connected with the help of the bracket plate to another member, that means the load transfer will be at some eccentricity from the CG of the column, and because of that each bolt will be subjected to a twisting movement also, in addition to the direct force which is distributed equally into the number of bolts. So additional torque will be present, and because of that additional movement will be coming onto the each bolt. That type of connection which is having some eccentricity, that is known as the eccentric connection. The third type of connection is known as the pure movement connection. And in this pure movement connection, what we are experiencing, that if a connection is provided in such a way such that on both the sides of the column, if we are having two members connected in such a way that they are applying the equal amount of force at the equal eccentricity, in that case these two forces will be forming a couple, and because of that only one moment will be acting, and that's why the connection is known as the pure movement connection. And the last type of connection is known as the shear movement connection. That means if in a connection both shear and the moment, both the forces are coming, then that type of connection is known as the shear movement connection. So if a connection is provided in such a way that a column is connected in a plane perpendicular to the plane of the load, then that type of connection will be experiencing a direct shear force, because if we transfer this P force at some eccentricity to the joint, then it will be transferring a force and it will be transferring a moment. So because of the force, each bolt will be subjected to a shear force, and because of the moment, each bolt will be subjected to the tensile force or the compressive force. That means a moment. Therefore, that type of connection is known as the shear moment connection. Now we will discuss the different failure modes of a bolted joint. Now the bolted joint can be failed because of the failure of the bolt, or it can fail because of the failure of the plate, because at the joint we are having two members, that is one is plate and other one is the bolt. So the failure of either thing may happen, and because of that the failure of the joint may take place. Now these failure are primarily classified into three categories, that is the shear failure, then the bearing failure, and the third type of failure is the tension failure, or that is known as the bending failure. Now that means there can be a total of 6 categories. So the first category is the shear failure of the bolt. Second category will be the bearing failure of the bolt, and other category will be the tensile failure of the bolt. Now the fourth category may be the shear failure of the plate. The next category will be the bearing failure of the plate, and the last category of the failure may be the tensile or the bending failure of the plate. So these are the 6 types of failure which may occur whenever we are providing a bolted joint. So we will try to look at them one by one with the help of some pictures. So the shear failure of the bolt, it will happen when both the plates are being pulled apart. That means it is subjected to the tensile forces. So because of that, the top member will be subjected in this direction, while the bottom member, which is connected at the joint, it is being pulled in the right direction. So the bolt which is present in the above plate, it will be subjected to a force in the minus x direction, while the bolt part which is present in the bottom plate, it will be subjected to the positive x direction. So because of that, it will be subjected to the shear force at the interface, and if this shear force exceeds the shear capacity of the bolt, then the failure of the bolt may take place, and that failure is known as the shear failure of the bolt. And in that failure, the bolt will tear apart. And as you can see from the diagram, that this is the actual picture of the bolt, that from the runout area, that is the area between the shank and the thread, it is being separated out. So that type of failure is known as the shear failure of the bolt, because it is the failure of the bolt. Now let's say if the bolt is having sufficient capacity, but the capacity of the plate has been reached. That means the limit of the plate capacity, it has been reached out. So in that case, what will happen? The failure of the plate will take place. That means the plate will tear apart. That means this bolt will not remove. So that means this bolt will not be removed from its position. What will happen when you are applying the shear force? Because of that, this portion of the plate, it will be prevalent on the connection only, while the rest of the plate, it will move in this direction. So this type of failure in which the tear out of the plate happens, that is known as the shear failure of the plate. Next type of failure is the bearing failure of the bolt. In this, when the bolt is subjected to the shear force in the different direction, because of the different shear forces applied on the bolt, the bearing action or the bearing area provided by the bolt will be varying, because the top portion is in the compression from the left direction, while the bottom portion is also in the compression because of the force from the left direction, but the middle part is in the compression because of the force from the right direction. So because of that, the bearing area is varying, and therefore the bearing failure of the bolt will take place. That means the anomaly will be there, and because of that, the area of the bolt, it will be reducing. Now this type of failure is not very common in the case of the bolt, because generally the bearing capacity is not reached, while the bearing failure of the plate, it is very evident. So when the capacity of the bearing in case of bolt is not reached, and the bearing capacity of the plate is reached, in that case the bolt will be stationed at its position, while the hole in which this bolt was provided, it will be enlarged, and slowly this plate will be experiencing a enlarged bolt hole. And as you can see, this was the actual shape of the plate which was provided, while upon application of the external force, this bolt hole has been extended, it has been enlarged in this shape. So this type of failure is known as the bearing failure of the plate. So this is very common. Now the next type of failure of the bolt, it may be because of the couple which is generated here, and because of the eccentricity between these two forces, that is known as the lever arm between these two forces, there will be a moment which will be generated, and because of that there will be a bending failure of the bolt. As you can see from this picture, that the bottom portion is subjected to this direction force, while the upper portion, that is the shank portion of the bolt, is subjected to the force in this direction. And because of that, there is moment action, and because of that the bending of the bolt is taking place, and that type of failure is known as the bending failure or the moment failure of the bolt. While the tensile failure of the bolt, it will take place when the bolt is subjected to the tensile forces. So usually that is not the case. So that's why the common type of failure is the bending failure of the bolts. Now the another failure which may occur, that is the tensile failure of the plate. That means when we are pulling the plates in the different direction, so because of that, when the tensile capacity of the plate is reached, so the plate may rupture, and because of that an opening will be made on the one of the plate or on both of the plate at the area of the connection, and that is because the tensile capacity of the plate, it has been reached. That means it has been exceeded now, and that's why the failure of the plate in the tensile manner is taking place. Now the last type of the failure of the bolted connection, which is an advanced case, that is known as the block shear failure. Now the two terms here, they themselves represent the meaning of this term. That means a block and a shear failure. That means the entire block of the plate will be torn apart because of the shear force. And as you can see from the diagram, let's say if this was the plate which was provided, this was the connection, let's say this was the another plate which is connected through the bolts here. Now if in this plate the entire block of the plate which is present between the bolts, if it is moving out with the force applied, then that type of failure is known as the block shear failure. As you can see in these two images, that in the first path of the block shear failure, the area of the plate which is present between the bolt connection, it is being torn apart. While in the second type of failure, it is possible that the when the failure is taking place, it is taking place because of the entire assembly of the plate which is provided below this line of the bolt. It may move apart. So because of both the possibilities, this type of failure may take place, and that failure is known as the block shear failure. So this completes this both the type of joints and the different failures which are occurring in the case of the bolted joints. In the next video, we will look at the design of the ordinary type of bolts, and after that we will see the problem based upon that and how do we design the bolted connection. So thank you.